All right, let's talk about geometric sequences a little more. And we're going to learn something today called explicit and recursive equations for those sequences. So let's start with a geometric sequence. We're going to try something just a little bit different here. First of all, what number do we start with in this geometric sequence? We start with a 3, of course. What's the common ratio? What are we multiplying by? We're multiplying by 2. Now these two numbers, especially the 2, is going to help us come up with a pattern from the initial term. So this is what I mean. We're starting with a 3. What do we multiply 3 by to get to the second term, 6? We're multiplying by 2. What do we multiply 3 by to get to the third term, 12? 3 times what is 12? We're multiplying by 4. Then from 3 to 24, we're multiplying by 8. The next term in our sequence would be 48. We're multiplying to get from 3 to 48, I'm multiplying by 16. So not only is there a pattern in my geometric sequence, there's actually a pattern in what I'm multiplying by. So let's take a look at these numbers, the 2, the 4, the 8, and the 16. I'm going to say that this 2 is the same as 2 to the first power. I'm going to say that 4 is the same as 2 to the second power. And 8 is 2 to the third power. And this pattern is actually going to continue as well. 16 is 2 to the fourth power. And this can go on and on and on. By the way, to get 3, or from 3 to itself, we multiply by 1, which is actually 2 to the 0 power. So let's take a look at the term number and what power of 2 we multiply to get there. So if I look at my first term, I multiplied by a power of 0. To get to my second term, I multiplied by a power of 1. To get to my third term, I multiplied by a power of 2. To get to my fourth term, I multiplied 2 to a power of 3. To get to my fifth term, I used a power of 4. To get to my sixth term, I would have used a power of 5, and on and on. To get to my 100th term, I would use a power of 99, right? So the pattern is we're taking the common ratio and we're taking it to a power that's 1 less than the term number. Like if I want to get to the 50th term, I would multiply 3 by 2 to the 49th power. So the pattern is to get to any term in my sequence, I'm taking my initial term and multiplying that by my common ratio to a power that's 1 less than the term number I want. Remember, n is the term number, so if I want the 300th term, I would call that a 300, right? A sub 300. And then my power that I would take the 2 to, sorry, that sounded funny, would be 1 less than that, would be the 299th power. This is what's called an explicit formula for this sequence. Explicit formulas are super beneficial in that they actually can help us find terms that are way off in the distance, and I don't have to write every single term of that formula down, or every term of that sequence down, in order to get there. So let me show you that again so that hopefully it will make a little more sense. here I have a geometric sequence, 2, -6, 18, and -54. First of all, what's A1? Our initial term is 2. What's our common ratio? What's R? What are we multiplying by? We're multiplying by -3. Remember, anytime you alternate from positive to negative to positive to negative, your common ratio is going to be a negative number. And let's look at the relation, or let's look at its explicit formula. To get any term in my sequence, remember n can be any number, I'm going to take my initial term, I'm going to multiply that by the common ratio taken to the n minus 1 power. How about this one down here, 16, 8, 4, 2. Our initial term is 16. Our common ratio, remember, we can't say that we're dividing by 2 because in a geometric sequence we only multiply. So to get from 16 to 8, and from 8 to 4, and from 4 to 2, we're actually multiplying by half, right? This next number is half of the previous number. So the explicit formula for this geometric sequence, I would say a sub n is 16, or my initial term, times by my common ratio to the n minus 1 power. If I were to write a general explicit formula, one that I could apply for every geometric sequence, I would write a sub n equals my initial term times r to the n minus 1 power. This is a general explicit formula. Remember, a sub n is any term that in the sequence. If I want the 75th term, n would become a 75. A sub 1 is my initial term, or the beginning number of my sequence. R is the common ratio, the number that I'm multiplying by. And n minus 1 would end up being 1 less than my term number. Explicit formulas, remember, are used to find any term. They're best, the explicit formula is best when you have to find a term that's far off. Like if I wanted to find the 200th term, I wouldn't want to sit down and write out the first 200 terms of my sequence. I would want to just use the explicit formula and it would take me right to the 200th term. We'll practice this in just a second. There's also something called a recursive formula. A recursive formula is simply notation that tells me how to find the sequence. Recursive formula, recursive means to write out every term in the sequence until you get to the one you want. That needs to go in your notes. I'm going to say that one more time. A recursive formula means you have to write out every term of the sequence until you get to the one you want. An explicit formula lets you jump ahead to a specific term. Again, the explicit formula allows you to jump ahead to a specific term. So like I said, a recursive formula is just notation based, right? In a recursive formula, there's two things that have to happen. You have to state where your sequence starts, and you have to say what happens to get your sequence. So where it starts is going to be a sub 1, right? So I would want to write whatever a sub 1 is. Then I'm going to put a comma, and then I'm going to say a sub n is, I'm going to take any term in, oh sorry, I should say this. A sub n is any term, right? To recursively find a pattern, I'm going to take the term before it. So I'm going to say a sub n minus 1. That means the term before, and multiply it by my common ratio. This is what a recursive formula looks like for a geometric sequence. It tells me where to start and to take the term before and multiply it by my common ratio to get the next term of my sequence. Before we leave this screen, I want to bring your attention back to our general explicit formula for just a second. Does this format look a little bit familiar? Maybe like an exponential function? An explicit formula, or I should say a geometric sequence, is simply an exponential function in disguise. So when you're writing an explicit formula for a geometric sequence, think exponential function. So let's practice. Here I've got a geometric sequence. A sub 1 is 4. Our common ratio, the number we're multiplying by, is negative 4. I'm going to write the explicit formula and the recursive formula. Why don't you pause the video for a second and try it on your own so that you can see if you're on the right track. Then resume the video and see if you got the same thing I did. All right, for an explicit formula, remember we write to find any term in the sequence. I have a starting value. I'm going to multiply that by my common ratio to the n minus 1 power. If I wanted to find, say, the 100th term of this sequence, I would put in a sub 100 equals 4 times negative 4 to the 99th power. In my calculator, I would put negative 4 to the 99th power and I would then multiply it by 4. And I would get a number that has about 61 numbers involved in it. So I'm not going to take the time to write it down right now, but it's going to be a very large number. When I ask you to use an explicit formula, I'll say something like find the 20th term so that it's not quite so large. And to find recursive formula for this, remember recursive formula has two parts. We have to say where it starts and what happens. So to find the next term in my sequence, I'm going to take the term before it and multiply it by my common ratio. So if I wanted to find the third term, let's say, I would take the second term and multiply it by negative 4. Remember, explicit lets you jump ahead to any term in your sequence. A recursive formula just tells you the pattern, but you still have to write out all the terms. Make sure to write down any questions that you have. We'll do a little more practice with this in class, and I will see you then. Have a fantastic day.